Hi guys, we're going to do a little lesson on scientific notation. What is it and why is it useful? It says here, as you can read, it's a way to write numbers in an abbreviated way, making it easier to work with these numbers. It is especially useful when expressing really big or really small numbers. It makes it easier to compare numbers because they are all in the same format. So scientific notation is a number between 1 and 10 times 10 to the something. So that's always the way it is written. The number, when I say between 1 and 10, what I'm always going to mean is this, that it is greater than 1, but also can equal 1. And it has to be less than 10. So 9.99999, that would work. But once you hit 10, that's a no. You should have moved it over one more place to make it a 1. You'll know what I'm talking about in a minute. So I'll say a number between 1 and 10 when we're talking about it. But what I really mean is that it is between 1 and 10 and can equal 1, actually. Okay, so it's always in this format right over here. Let's see if I can get my little pointer. So here, the coefficient is this number here. That's the number that will be between 1 and 10. And then you will have time 10 to the something, some exponent. That will depend on how many places you needed to move the decimal point. The base is this 10 here. So we know that just from doing powers, that when a number is raised to an exponent, the number being raised is called the base. So here are a couple of examples of scientific notation. 45,000, that would be standard form. That written in scientific notation is 4.5 times 10 to the fourth. How did they get that? Well, if you take 4.5 and you multiply it by 10 to the fourth, that would be making it bigger. Our number system is based on tens, so we just have to move the decimal point places left or right. 10 to the fourth is really the number 10,000 if you multiply it out. And multiplying by 10 to the fourth, or 10,000, which has 4 zeros, you know from previous years, you would move the decimal point 4 places to the right and make the number bigger. So if you took this decimal point right here and went 1, 2, 3, 4 places, it would make the number 45,000. The decimal point would now be right here. Similarly, for 7.6 times 10 to the negative 4, this makes it smaller. Now you know that negative 4 as an exponent really means 1 over 10,000. So the fraction. So when we multiply by a fraction, we're making the number smaller. So because, again, our number system is based on tens, it's super easy. We just scoot the decimal point over. In this case, 4 places also, but to the left. 1, 2, 3, 4. And that would make this number right here, 0.00076. There is a little video right here about scientific notation. So this will be on Canvas, and you can play that if you'd like to. So here are some examples of some really big numbers that would be useful for scientific notation, that would make scientific notation useful. The planet Earth weighs about this many kilograms, and that number written in scientific notation is 5.9722 times 10 to the 24th. Why the 24th? Well, the decimal point is currently here on the standard form number, right at the very end of it. And to make this number a number between 1 and 10, we need it to be right here, between the 5 and the 9. That's the only place. If I put it here, it's a 59. Here, it's a 597 point something. Here, it's 0.5, not between 1 and 10. This is the only place. There will never be a question as to where the decimal point can go. It's only one place. So right here. So in order to move the decimal point from the end of it to here, it was 24 places. And how do you know whether it's positive or negative? Well, if you went to the left to get the decimal point there, then you're going to make it positive, because you're going to want to multiply and move it to the right to get that number back, right? So I would want to make it huge and move it to the right 24 places, not make it really tiny and move it 24 places to the left. So you can kind of rationalize that if you forget at any point. So similarly over here, planet Saturn, a similar example. Notice though, that it's easy now because look at all these zeros. It's very hard to compare the two numbers. But when they're written in scientific notation, we can see that they're both numbers between 1 and 10, kind of close. But the exponent itself, look at 26 for Saturn, 24 for Earth. So Saturn is larger and has a couple more zeros in a couple more places. So now we have a really tiny, small number. An atom is 1,000,000 times smaller than the thickest human hair. So this is a nanometer. It's a fraction of a meter, right? A tiny, tiny fraction of a meter. So that number in scientific notation is 1 times 10 to the negative 10. So here's the decimal point for scientific notation. You would move your decimal point 10 places to the left to get this standard form number back. Let's try some examples or explain how we get the standard form to scientific notation. So the distance around the Earth at the equator is 24,901 miles. If we were going to write that in standard notation, in scientific notation, here are the questions you ask yourself. Where would the decimal point go to make this a number between 1 and 10? It would go right there. There's no question, between the 2 and the 4. So here is the number that it makes between 1 and 10. How many places did you move the decimal point to get there? So it was here. It was 1, 2, 3, 4 places to the left. So the number written in scientific notation is 2.4901 times 10 to the 4th. So again, we moved it to the left. So we're going to have the decimal point be positive, mainly because in order to get the original number back, we would want to multiply it. We're multiplying it by a big number, 10,000, and moving it to the right, making it big again. The average piece of paper is 39 10,000ths inches thick. That, written in scientific notation, again, where would the decimal point go to make this a number between 1 and 10? It would go here between the 3 and the 9. And that moves the decimal point 3 places to the right. So here's the number between 1 and 10 times 10 to the something. That something is a negative 3 because we went 3 places to the right. And in order to get it back, we would multiply by 10 to the negative 3 and move it to the left and make it small again. Mount Everest is about 29,000 feet high. That number in scientific notation. Again, here's your question. Where would the decimal point go to make this a number between 1 and 10? Right here, between the 2 and the 9. And how many places did you move the decimal point to get there, and in what direction? Well, the decimal point was here at the end of it. I went 1, 2, 3, 4 places to the left. So that number written in scientific notation is 2.9 times 10 to the 4th. 1 M&M weighs about 0.00195 pounds. Tiny, tiny fraction of a pound. Where would the decimal point go to make that a number between 1 and 10? So it's currently here. I want it to be here. It's the only place. If I put it here, it's 19.5. If I put it here, it's 0.195. 1.95 is the only acceptable spot for that decimal point to be in scientific notation. How many places did you move it? 1, 2, 3 places to the right. So this number written in scientific notation is 1.94 times 10 to the negative 3. If I wanted to get the standard form number back, I would look at my exponent and I would go left 3 places and I would get that number back. As of August 31st, 2020, the U.S. national debt was estimated to be $26.7 trillion, which is this number in standard form. In order to put that horrifying number into scientific notation, the decimal point is currently here at the end of it, as it should be. We are going to move it 3, 6, 9, 12, 13 places to get it to be between the 2 and the 6, which is the only place to make it a number between 1 and 10. So this number in scientific notation is 2.67 times 10 to the 13th. Again, once you put in scientific notation, ask yourself, did I put the right exponent here that would make it go left or right and get the number back? So you want to be moving it to the right and making it huge again, and that's what the positive exponent would do. Distance from Earth to the moon, 238,900 miles. We want to put the decimal point from here to here. And that is 1, 2, 3, 4, 5 places to the left. So in scientific notation, that is 2.389 times 10 to the 5th. So now you try some. Please copy the table into your notebook. Press pause while you do this, and then give these few a try. I'll pause for a moment so you can catch it before the answers. Here comes the answer key. So I hope you got them all right. So this is in standard form and then in scientific notation. All right, more practice. See you soon.